All right, so today we're going to do the 12-5 day 1 notes. We're going to learn the square root method. This is going to allow us to find the zeros of a quadratic that aren't integer numbers or maybe nice decimals. We've done everything at this point that has nice numbers, but there's a whole world of crazy square roots out there. So we're going to figure out how to solve those. So firstly, what is a radical expression? Well, radical expression is any expression that contains a radical. Well, a radical is this symbol right here. A radical is that, looks like a house, kind of. Anything under the radical inside is called the radicand. And this little number on the outside is called the index. So every radical has 3 parts. So it's got the index, the radical, that symbol, and then anything inside is called the radicand. For the most part, we deal with square roots in this class. And we don't like to always write a 2 there if we don't have to, because we like to make things as simple as possible. So when there is no root index given, it is assumed to be 2. So if I just write root 36, it's assumed that I'm saying square root of 36. If I want some other root, I will for sure put a number out there. I'll put a 3 or something. But if there's no number, then it is the square root of 36. All right, so talking about finding the square root. Well, finding the square root of a number is finding the inverse operation of squaring a number. Remember, squaring a number is saying the number times itself. So 2 squared is 4. Well, square root of 4 is saying what times itself is 4. So the square root of 4 is 2 because 2 times 2 is 4. The square root of 16, I ask myself, what times itself is 16? Well, 4 times 4 is 16. And lastly, we can do the same thing for variables as well. What times itself is x squared? Well, that's x times x. That's x squared. But we actually have 2 different answers because we don't think about it very often, but the square root of 4 can actually be a negative 2 because negative 2 times negative 2 is still a positive 4. So every square root question actually has 1 positive and 1 negative answer. Square root of 16 could also be negative 4 because negative 4 times negative 4, is a positive 16 as well. So I can have 2 negative numbers multiply to give me a positive or 2 positives. So either way, every positive square root has 2 different answers, 1 positive, 1 negative. I'm going to tell you which answer I want. I don't want you to always tell me both answers. So I'll actually put a symbol out front telling you which answer I want. So if I want a positive root, I'm going to give you just the square root of something, and you just tell me positive whatever. If I want the negative square root, I'm actually going to put a negative sign out there. I'm going to say, give me the negative answer of square root of 4, and I'll put that negative on the outside for you. This, however, is different than saying maybe the square root of negative 4. So it makes a difference if your negative is on the outside or on the inside. So I'm going to be asking for negative root 4, not root negative 4, because root negative 4 doesn't actually exist. It's a complex number because negative 4 is 2 times negative 2. I can't have 2 times 2 or negative 2 times negative 2. There's no way to multiply the same number twice to get root negative 4. So this doesn't even work. I can't get a positive 2 and a negative 2 to pop out. So negative square roots, they don't exist for us. They are imaginary or complex, but for the purpose of this class, they don't exist. That's a non-real answer. Okay, so going over here to square root 49. Well, hopefully you know square root of 49. Here's your perfect squares list. You're going to need to memorize. So let's go ahead and write that on there. You need to memorize this list. Most of you probably already know 1 through 6. But you do need to memorize 7 through 15. You need to have that list memorized all the way up to 15. You may not be getting a calculator on some of these questions. You should not need to plug this into the calculator. Also, if you know your perfect square roots, it makes solving these so much easier. You can just do it in one step instead of having to do it in the long step. And I'll show you how to do that at the bottom. But either way, square root of 49, we go over here, square root of 49 is 7. And I wanted the positive answer because I didn't tell you anything. So just leave your answer as positive 7 and you're done. All right, over here, I want the negative square root of 81. Well, the square root of 81, what times itself is 81? Well, the square root of 81 is 9. But I told you I want the negative answer, so just tag on a negative. I just want negative 9. Because negative 9 times negative 9 is root 81. I wanted the negative answer there. All right, over here we have positive negative. That little symbol together is saying positive negative. Well, let's ignore that for a second and just do the square root of 100. What times itself is 100? Well, that's 10. But I want the positive and negative answer, so you can just actually tag on the positive negative symbol, or if you want to, you can actually say 10 comma negative 10 if you want to write those answers separately. Doesn't matter to me which way you write it. I'll probably write positive negative 10 most often just because it's the simplest or the shortest. So I like that one. All right, go ahead and try this last guy on your own for just a second. Pause the video if you need to. Okay, so square root of 1 is just 1, but I want the negative answer, so just tag on that negative sign. So let's continue by talking about how to reduce these radical expressions. So there's 3 properties we're looking for basically. We want there to be no perfect square factors other than 1 in the radicand. So we don't want to have anything that could have a 25 times the number or 16 times the number. We don't want to have any of those things hidden on the inside. We don't want to have any fractions in the radicand, and we don't want any radicals in the denominator. We don't worry about these two today. Today we're just going to deal with getting rid of those perfect square factors out of the radicand. To do this, we need to have a property. So the product property says that the square root of a product equals the product of the square roots. What that means is, if I have the square root of a couple things multiplied, I'm able to break those things apart and actually take the square root of each thing separately. So the square root of 6 would be the square root of 2 times the square root of 3, just breaking it into its parts. That gives us the option for 2 different methods. And I'll show you how to use each method, and you can pick whichever one you want to and stick with it. If you know your perfect squares by heart, then method 1 might be a little quicker. Method 2 always works. Sometimes it's the best, but sometimes it takes a little bit longer. It just depends on where you're comfortable with your square roots. So I will show you how to use both methods, and you just stick with what you want. Okay, so method 1 is we're going to try to find the largest perfect square that divides evenly into the radicand. So you're going to look at 24, and you're going to think of just perfect squares. So I know my perfect squares are 1 and 4 and 9 and 16 and 25 and et cetera, et cetera. I ask myself, do any of these numbers go into 24 evenly? Well, 25 doesn't, 16, 9, 4 does. So then I would say 4 times whatever is 24. So 4 times 6. So I break it into one perfect square and then whatever else happens to be the number. Then I'm actually going to break it apart. I'm going to have the square root of 4 and the square root of 6. Well, the square root of 4 should be a perfect square if you chose it properly. I like to cross out my number and write the number on the outside when I do the math, just so I don't accidentally keep that root 4 on the inside. But the square root of 4 is 2. It should have a perfect square. That guy is now on the outside, and this root 6 is stuck inside the radicand. He's not able to come out. So that's method 1. Method 2 is using a factor tree. So instead of looking at just the perfect squares, I'm going to look at any factors, any prime factors. So I'm going to pretend the radical is a barn, because it does look like a house anyway, and the factors are animals. So let's put little arms and legs on this guy. Oh, those are terrible animals. Okay, these are all animals now. So we got animals on the inside. And it's silly, but silly things work. So root 27, you would ask yourself what multiplies B27, which I didn't show it here, but it's 9 times 3, and then 9 is 3 times 3. So 27 is 3 times 3 times 3. All right, now the way the barn method works is once you've broken everything down into all of its basic elements, everything is down as far as it can go. You don't have any 4s left over. You got 2s and 3s and 5s. I'm going to break my animals up into pairs. So, and I want the same things paired together. I'm not going to pair a 2 and a 3. Those are not the same animal. They're not friends. 3s like 3s and 2s like 2s. So I'm going to break them into pairs, and once they're paired, they can leave the barn together. Anyone without a pair is stuck on the inside, so if a factor has no partner, it must stay inside. And all the numbers on the inside get multiplied together, and all the numbers on the outside get multiplied together. And I'll show you what that means once we get a little further in. So anyway, here are my three little guys. I'm going to pair these two animals together, and I'm just going to bring that number out. So I've got a pair of threes that I brought out, and this guy had no partner, so he just gets left on the inside. So those threes, I just brought a pair of threes out. I just write the 3 one time, and that 3 is stuck on the inside. So I'll show you how that works when we actually do a couple examples. So I'm going to show you how to do both methods. So method 1 is when you ask yourself, what is the greatest perfect square that goes into 45? So I like to list my perfect squares on the side of my paper just so I can have them there. So I know 1, 4, 9, 16, 25, 36, and if I need any higher, I go higher. So I ask myself, do any of these numbers go into 45 evenly, and if so, what's the largest? Well, if you need to, which you don't have your calculator, so you wouldn't be able to do this, but I know 36 does not go in, I know 25 doesn't go in, surely you can divide 45 and see that 16 doesn't go in, but 9 does go in. So 45 is root 9 times root, and you've got to know your multiplication tables. So 9 times what is 45? Well, 9 times 5. Because I've broken it into two radicals, I'm able to just take care of each of them separately. Well, the square root of 9 we already had earlier, I think, or maybe we didn't. The square root of 9 is, and I'm just going to cross it out and put the answer, the square root of 9 is 3. So that guy's able to be on the outside now. He is no longer a radical. So I like to cross it out so you don't accidentally leave it inside the radical. Next, root 5 does not have any perfect squares. He is stuck, so he is going to just stay inside the radical. So that's that answer. If, however, you don't know your perfect squares or you just want to do another method, that's totally fine. Method 2 is I'm going to say root 45, and I'm just going to do a factor tree. So I'm going to say 45, and however you get to it, doesn't matter. You can do 9 and 5 as well. And then 9 is 3 times 3. So I'm going to list all of these factors together. So that means that root 45 is root 3 times 5. You don't actually need to break these guys into their own radicals if you don't want to. It's perfectly fine to leave like this. I would always make sure, though, that when you finish, you check your answer. 3 times 3 is 9, times 5 is 45. So make sure you actually get your answer back. Then you're just going to go ahead and look for pairs. So 3 and 3 are the same letter, same animal, whatever. So these guys are able to come out of the barn. And that root 5, he doesn't have anybody, so he is stuck inside the barn. So he becomes root 5, and he's stuck forever. So same answer either way. It's however you want to do it, totally fine. All right, so root 104. Well, I'm going to go ahead and do the same method I did last time. I'm going to, and you might actually need, I mean, it's kind of hard to divide these in your head, so you might need to do some long division. This one, method 2, might be better. But this one, you're going to try to figure out what multiplies into 104. If you work down your list, I mean, I know the answer. 4 is actually the biggest one, so it's actually root 4 and root 26. Root 26 does not have any perfect squares in it, so this guy is done, but this one's a little harder to spot, so this one, method 2, actually might be better. But we'll go with this one anyway, stick with it. So root 4 is, this guy is a 2, which means on the outside I have a 2, on the inside I have a 26. So if you were able to do that division, that was not too bad, but for most of you, I imagine, I mean, I probably would have actually done method 2 on this one. I would have done root 104, and I would have broken it down into its parts, because 104 is kind of big. So that is, sure, let's do 4 and 26. Well, 4 is 2 and 2. 26 is 2 and 13. So those are all the factors. I'm going to go ahead and list those guys out. 2 times 2 times 2 times 13. I'm going to look for some pairs. I only have 2 2s. So the only thing I can bring out is I can bring out a group of 2s. On the inside, though, 2 and 13 are stuck. So I can't bring them out, so I'm going to multiply their answer on the inside, and I'm going to get 26. So I was only able to bring out one pair.